Make voice search more natural. This paper compiles new dataset and implements two novel modules in the QA architecture. So today I'm reading Conversations with Search Engines papers and related papers overview. I will go through this rather quickly because I had already some attempts on this. So Conversation with Search Engine ran 2020 et al. So they would like to allow additional retriever in context of previous queries. So the user, for example, asks, tell me about the Bronze Age collapse, and the engine responds, it may be because of the shortage of tin that is necessary for the melt of bronze that forced to seek an alternative of this metal. Then the user may want to retrieve additional information and asks, what is the evidence for it? And now the engine is in a challenging position. It needs to know what is the user asking about. It needs to know what is relevant answer. It needs to do quick search over large amount of data and at the same time, retrieve very short answer. So this is the challenge for this paper. Interesting idea. So first, a little bit about machine comprehension task, which is related to this. So there is the CNN Daily Mail dataset where each data point in this dataset is composed of context, which is a passage with marked entities, and a question, which is a sentence with one fill-in blank entity, and you need to answer correctly which entity should be in the answer. So the picture on the right is from the thorough examination of CNN Daily Mail reading comprehension task. And another interesting part is this bidirectional attention flow from SEO 2019, which was a paper about machine comprehension. The core idea is using these jointly contextual context plus query embeddings, LSTMs, where they contributed by replacing summarization with an attention. So that was the novel contribution. They used bidirectional LSTMs because no transformers existed at the time yet or were not used very commonly. At 2019, they achieved state-of-the-art on Squad and CNN Daily Mail. And so the architecture is on the right. I will say a little bit more about this bidirectional attention flow, which is also used in the conversation with search engine. So at the bottom, they start with the context and query, and they need to know start and end of the passage, which is to be used for the response and a result. So they take both context and query, get the glove embeddings, characters, CNN embeddings. They pass it through the bidirectional STM layer. And then they pass it both to this bidirectional attention flow, which is the core. After this core, there are only just another LCMs, then some softmax, and start and results. So what is this core? So this core is composed of two attention mechanisms, which are then combined into one with some sort of concatenation Hadamard product. So these two attention mechanisms both use trainable similarity matrix, which is basically a matrix of similarity between the context words and query words. The similarity is not exactly a cosine similarity, but I think the cosine similarity can be is sort of just one possible learnable result of this. So context to query. Attention essentially gives you, for each context word, the most important query word vector. Of course, it uses softmax, so it needs to be differentiable, but this is the idea. So this query to context attention, which is the second part, gives you some of the most important context vectors, and it is tiled in this matrix t times. Doing this, they get two matrices which have one dimension the same, and then they utilize this to sort of to always have this one controlled dimension to construct this resulting output. This matrix, which is a query-aware representation of each context word. So at the end, they have this query-aware representation. which is basically a concatenation of those mentioned matrices before. Okay, so conversation with search engines and how they actually use what I mentioned. So they have these steps they need to go through. So they need to understand previous and current query, search for relevant messages based on the current query, and the previous one in the light of the previous one. They need to identify relevant passages from those retrieved from the search engine. In those passages, they need to identify supporting text. And from that supporting text, they need to generate response in a conversational manner. So they start with queries and passages. They pass them through transformer, get query tokens, passage tokens. Then they again do this similarity matrix, as I mentioned, and build bidirectional attention flow. And then from dynamic contention network, they use this idea of iteration over several potential answer spans to avoid falling into earlier minima. I think that is what they use there. Maybe they use some sort of also another attention. I'm not quite 100% sure on this. So supporting token identification. So they get these, now they identify the passages, but they would like to know which text in the passages is good for response generation. That's what they call supporting token identification. They identify tokens which should be used. So they use just a heuristic based on the idea, based on building a function from idea of rare tokens in the ground truth response and their neighbors being more likely to be present in the response answer. Using this, they train this probability of each token being in the response, and they use it. Okay, response generations. Transformer, they use again transformer there. They pass all the previous inputs, and they use 3 different generators which they combine. They have this vocabulary generator, query pointer generator, and they also have this prior aware passage pointer generator. This is one of the new modules they proposed. So to conclude, they applied state-of-the-art methods from the other tasks to build module a newly constructed dataset. I think this is really nice. They really constructed new dataset for this. They use this Amazon Turk, the laborers to create answer. They hand checked the dataset, so it's probably quite good quality. And they proposed 2 new modules, the supporting token identification and prior aware passage pointer generator. I haven't gone deeply on the second one, and just scratches surface on the first one. So that's all. I hope you like it. Please dislike and unsubscribe, and please don't leave comments, and if you have any suggestion. Okay, see you next time, bye.